All right, so Unit 9 is on stoichiometry. So basically, stoichiometry is just when we use a balanced equation. So we're going to use the coefficients of a balanced equation to go from like substance A to substance B. So the substance A and substance B have to be in the same equation. So in the equation that's in the notes, we have ammonia plus oxygen yields water and nitric oxide. So if you were to balance this equation, you would get, let's use a fun color. You would get 4, 5, 6, and 4. Okay, we're not going to go over balancing because y'all should know how to do that by now. So the numbers that I just put, those are coefficients. So those are the numbers that we're going to use to balance. So say I have a problem and I give you a certain amount of, say, ammonia. So I gave you 2 moles of ammonia, and I want to know how much water can be formed. Okay, to go from 2 moles of ammonia to how much water is formed, you have to use the coefficients, because these coefficients, this number right here, like the number 4 and the number 6, that's saying that in order for this reaction to take place, okay, so for the reaction to happen, you need 4 moles of ammonia. Okay, that 4 moles of ammonia has to react with 5 moles of oxygen. And when this happens, you will get 6 moles of water plus 4 moles of nitric oxide. All right, that is what this equation is saying. But the question that I asked you is, what if I give you 2 moles of ammonia? And I want to know how many moles of water. Okay, that's basically what I asked. So we are going to use these coefficients, that 4, 5, 6, and 4, when we have substance A. So in this case, substance A is ammonia because I put 2 moles above ammonia, to go to substance B. And in this case, substance B is water. Okay, so this is mole to mole conversion. All right, everything that we've done up to this point has been like grams to moles or liters to moles or atoms to moles, but it's all been of the same substance. So it's all been like, say I give you 5 moles of oxygen, how many grams of oxygen do you have? Okay, it's all been the same substance, but this time we're going to use a chemical equation to go from mole of substance A to mole of substance B. Okay, and to go from here to here, you have to use coefficients of a balanced equation. It has to be balanced. If it's not balanced, your numbers are going to be wrong. All right, so let's work a problem. So the way that I like to work these problems, if I were with y'all right now instead of social distancing, we would have learned it this way the whole time. I like to work them by putting what I'm given on top of the equation and using the equation as like my conversion factor. It'll make more sense when I do it. All right, so in the PowerPoint, one of the questions says, how many moles of water are produced if 2.00 moles of oxygen are used. All right, so one thing that I also normally put is like if 2.00 moles of oxygen are used, and I normally put something like with excess ammonia. Okay, the reason I do that is because this whole part with excess ammonia just means that the reaction is NH3 plus oxygen yields water and nitric oxide. Okay, if I don't tell you that I'm adding the ammonia, then the reaction that you see it wouldn't happen. Like, you have to have ammonia in there for this reaction to take place. Now, these numbers that I'm looking for only apply to the oxygen and the hydrogen, but the ammonia has to be there in order for the reaction to take place. So the with excess ammonia will make more sense when we start talking about limiting reactant. But right now, you just need to know that the ammonia is there and it's not limiting any of our problem. Okay, so let me erase some stuff just so that we can be more clear. Okay, so the problem is how many moles of water are produced if you have 2 moles of oxygen. So the first thing we have to do is make sure we have a balanced equation. So let me use different colors. It's 4, 5, 6, 4. Okay, so what you're given 2 moles of oxygen. So I put 2.00 moles of oxygen up there. And you're asked for how many moles of water, okay? So now you can see that I have my given and I have to get to my goal. And to get there, I'm going to use this equation right here, okay? So no matter what, you always start with your given. So your given is 2.00 moles of oxygen. Okay, and since I'm given mole of substance A and I need to get to mole of substance B, I'm going to use these coefficients to get from oxygen to hydrogen. So I'm going to multiply it by, don't freak out. I know some of you are like, stop, don't put the bracket, it'll be okay. You have to multiply by the conversion to get there. So since mole of oxygen is on top, I want oxygen to go on bottom, okay? Now, this can be written 2 different ways. Since oxygen's on bottom, this 5 goes with oxygen. Some people are just going to put 5O2, but you can also put mole if that makes you feel better. Okay? And since I'm trying to get to water, I want to put water on top. Now, what number goes with water? That is the number from the equation, okay? Because what that's saying is that 5 moles of oxygen are turning into 6 moles of water when it's reacted in this equation, okay? So now that cancels out mole of oxygen and you are left with moles of water. So you solve and you say 2 times 6 is 12 divided by 5. So 2 times 6 is 12 divided by 5 gives me 2.4 moles of water, okay? And that is your answer because that is what you were searching for, okay?